Hello knowledge seekers, this is Showman from Oil and Gas Field Quality Control. This is a continuation video of the water filling. This is pertaining to the subject chemical treatment of Hydrotest water. We need to have some good idea about the types of chemicals available in the market. The calculations means the ratio with the Hydrotest water, how much chemical we should inject. Let us start. Some important definitions of biocide: a chemical added to preserve fluids and systems by controlling the proliferation and growth of microorganisms that can affect corrosion and system cleanliness. General aerobic bacteria or GAB, prokaryotic bacteria and archaea microorganisms that obtain their biochemical energy and reproduce in the presence of oxygen. For example, acid-producing bacteria or iron-oxidizing bacteria. Means if we allow them to grow in the Hydrotest water, if we not add the chemical, this acid produced from by these bacteria will corrode or even eat the line material. Hydrostatic test, we know this, a pressure test conducted to piping or equipment or pipeline by subjecting it to internal pressure using water or other approved liquid as the test medium to ensure strength of the system or integrity of the system, that there is no leak at the test pressure. Oxygen Scavenger, a chemical added to the process or water to help remove or decrease the level of dissolved oxygen in the system to control the corrosion. If we reduce the dissolved oxygen, then this type of general aerobic bacteria, GAB, cannot live and they cannot produce any acid or something. So oxygen more means corrosion more. So we need to control the dissolved oxygen by adding this type of chemical. Generally, water coming in contact more than 14 days or more than 30 days, we are keeping the water in the system, we have to add this oxygen scavenger and biocides. Pitting resistance equivalent number, PREN, a qualitative factor developed to predict the pitting resistance of a corrosion resistance alloy or CRA based on a minimum chromium, molybdenum, tungsten, nitrogen contents. PREN can be calculated using below equation as per NACE MR 0175 or ISO 1515 PREN reminds me the formula of carbon equivalent. So PREN formula can be described in this way: chromium percentage plus 3.3 times of percentage of molybdenum and 0.5% of the tungsten content plus 16% of nitrogen content of the material. Then you can calculate the PREN number of the material. Sulfate-reducing bacteria, prokaryotic bacteria or archaea microorganisms that obtain their biochemical energy by metabolizing sulfate with natural organic compounds to produce hydrogen sulfide and sulfate, H2S, HS, as metabolic byproducts in anaerobic environments. So there are two types of bacteria. One, you can see the general aerobic bacteria, GAB, which can produce acid kind of thing with the help of oxygen present in the water. And sulfate reducing bacteria, they don't need any air. They are just reacting natural organic compound and harming the system. So both should be lower in the Hydrotest water. Total dissolved solid, TDS, a measure of the combined content of the inorganic and organic substances contained in a liquid. And total suspended solids, TSS, a measure of the dry weight of the particles contained in a liquid trapped by a filter. Okay, enough of the definitions. Now let us see this PREN number table. There are 5 subcategories to align the water quality, and we need to decide based on this subcategory the requirement of chemical treatment and layup requirement. So basically 3 category, 1, 2 and 3. 2 has 5 subcategory, A, B, C, D, E. So PREN number if less than equal to 30 is A, 30 to 40 is B, over 40 is C, and copper containing alloy is D, and titanium alloy is E, and 3 is completely non-metallic, RTR, RTP, HDP, So you can see there are some reference PRN number also here. We have to use this table to find the final requirement of water quality. So for all the categories, starting from category 1 and 2, the total bacteria count per milligram of water should be less than or equal to 10 to the power 4. SRB count, sulfate-reducing bacteria, per milligram should be less than or equal to 10 cube. Oxygen concentration for category 1, 2A and 2B should be less than or equal to 20, and category 2, C, D, E and category 3, there are no restrictions for oxygen content. pH range for all the waters, for all categories, 6 to 9, and the total suspended solid for all the categories required less than or equal to 50 parts per million. Without clean water, test should not be done, because if water has a lot of suspended things and water is dirty, full of foreign materials inside, this will be stuck in the system and then it will be very difficult to clean later on. So we need a clean system after hydrotest. So water cleanliness or clear water is mandatory for all categories. Chloride concentration parts per million is only restriction for category 2 and category B. Category 2A is basically stainless steel kind of material where chloride affects it's more, so it should be less than or equal to 50 parts per million, and for alloy steel it is less than 500 parts per million. For other categories and non-metallic, there are no such restrictions. Let us come to the oxygen scavenger here. An oxygen scavenger shall be added in case of wet layup and also to the hydrotest water. Category 1 material, when the water contact time is exceeding 14 days, we need to add oxygen scavenger. Category 1 material, regardless of the contact time for any of the hydrocarbon. If the line is for hydrocarbon, then you need to put oxygen scavenger from the beginning. Okay, the chemicals used shall not have any adverse effect on the pipeline service as per API RP 1110. So the chemical you use, it might kill the bacteria, but in parallel it is also damaging the pipe material or corroding or eating the pipe material, also not acceptable. So it should be compatible to the pipe material also. Category 2AB materials, regardless of contact time, you need to add oxygen scavenger, which will keep the dissolved oxygen level very low within the acceptance limit for prolonged period. Biocides. A biocide shall be added in case of wet layup and also to hydrostatic testing water in the following conditions. Category 1 material, when the total water contact time exceeds 30 days, you need to add biocides. Category 1 material, when there is hydrocarbon, you need to add from the beginning, when the service is hydrocarbon. The chemical used shall not have any adverse effect on the pipeline at per same condition, API RP 1110. Category 2AB material, regardless of contact time, you need to add biocides. Category 2 CDE material, when the total water contact time exceeds 30 days, you need to add this one. Hydrostatic test means category 3, there are no requirement of such adding of oxygen scavenger or biocide, because it never reacts with the non-metallic things. Hydrostatic testing of mixed material categories and or subcategories is not recommended. If different categories are part of a same hydrostatic system, then you need to make a chemical treatment after the hydrotest to make sure that the water is not contaminating the pipe material itself. For chemicals, some important requirements. When multiple treating of chemicals are required, then the proposed chemicals shall be compatible and do not lead to adverse reaction. Function of some or all of the chemicals. A non-oxidizing biocides shall be used when oxygen scavenger is required. Separate proportioning pump shall be used for each chemical to avoid adverse reaction. A spare shall always be provided to ensure adequate chemical doses. The oxygen scavenger, biocide and corrosion inhibitor shall not be mixed prior to injection. Multi-component products as provided by the chemical vendors are exempt from the pre-mixing restriction. Any treatment chemicals shall be continuously injected at a rate that will provide the specific concentration while filling the system with water in preparation for the hydrostatic test. The chemical injection and hydrostatic testing water rates shall be monitored on site as per approved procedure. Here are some acceptable oxygen scavenger. You can see the scavenger catalyzed Na2SO2, sodium sulfite. The typical feed ratio by weight is 10. 60 kg drum, 91% anhydrous powder. It is the availability and shall be dissolved in water to give a 3 to 5% solutions. So when you use, you have to dissolve it in the water to get a 3 to 5% solution. Catalyzed sodium metabisulfite, it has also the feed ratio of 10, 25 liter drum. It is available in the market, where 25% weight percentage of sodium metabisulfite solution. So it is actually tending to react with atmospheric oxygen over time, more acidic than ammonium bisulfite. Ammonium bisulfite has a feed ratio of 10. It is available in 55 gallon drum of 37 weight percent solution of sodium ammonium bisulfate. Chemical is often selected for use due to ease of handling. However, ammonium ion can provide an additional food source of bacteria. So these are some approved oxygen scavenger by our client, but there must be more, so you can select from there. Let us have some simple calculations how to select the amount of oxygen scavenger we need. Calculate first the mass of the oxygen in the solution with the machine, where you can find the dissolved oxygen percentage. Multiply the mass of oxygen in the solution by the feed ratio. In the previous table, we can see the feed ratio is 10. Then add more 20 milligram per liter. Take into account the concentration of the oxygen scavenger in the supplied chemical. Example calculation, how much ammonium bisulfate will be required to treat 10,000 liters of water containing 8 milligram per liter of dissolved oxygen. First, we need to take the feed ratio, which is 10, multiplied by volume of oxygen content. Where you get this? From the kit, we have dissolved oxygen kit. From there, in the Hydrotest water, you will find the oxygen content. Multiply with feed ratio plus volume into residual oxygen scavenger concentration. So concentration here is 37% divided by 0.37. So you can see in the result over here, we assume here the approximate 2.7 kg of 37% weight ammonium bisulfate, assuming the specific gravity is 37% weight is 1.185. So you need to know this. So milligram converted to liter by multiplying it with the specific gravity. So we need 2.3 liters of ammonium bisulfate to be injected total for 10,000 liters of water. Here are some safety data sheet which is being supplied by the oxygen scavenger manufacturer. Just for your information how it looks, it is a mandatory attachment. Dosing and metering pump. This is the pump from where we are injecting the oxygen scavenger or biocide to the system. So what is a dosing or metering pump? A dosing pump, also called as a metering pump or dose pump, referred to a positive displacement pump well designed to push a chemical or similar substance to the flowing gas, stream or water. These pumps are usually small and offer accurate flow rates with maximum control. They make an essential part of the integrated metering system developed to perform automatic chemical dispersion. The dosing pumps enables the process of dispersing certain amounts of fluid while also maintaining the flow. Working principle: a dosing metering pump sucks a particular amount of liquid and feeds to the pump chamber to add liquid in the process. The pump gets controlled with an electrical motor or air actuator. It has a controller to switch the pump on and off, hence regulating the flow. Types of dosing pump available in the market: diaphragm metering pump, plunger metering pump, peristatic metering pumps, lobe pump, solenoid dosing pumps, multi-diaphragm dosing pumps. Where it applies. For us, it is applying to inject this Oxygen Scavenger and biocides, taking care of maintaining a continuous flow rate irrespective of the fluid velocity of differential pressure, maintaining system parameters like pH through the delivery of variable flow, injecting discrete dosing procedure especially for batch processing, use of metering in various industries like water treatment, waste processing, pharmaceuticals, chemical processing, power generation, oil and gas extraction, petrochemicals, and also not mentioned here is Hydrotest. Liquid may range from fragrances or the pigments used in the production of food, toiletries. It could also be alkaline solutions or acidic solutions utilized in water treatment and chemical process. You can see some models of dosing pump available in the market. You can see where we are using the injecting pump. On the way we are injecting Oxygen Scavenger and biocides in the system where the filling is ongoing at a specific rate. Let's say, for example, 10,000 liter of water we need to fill. We need to arrange 2.3 liter of ammonium bisulfate and a dosing pump, and we will inject this 2.3 liter at an uniform rate throughout the filling procedure, and we will decide the flow rate by calculating 10,000 liter takes 10 hours. So within 10 hours this 2.3 liter should enter in the system based on the time. We need to calculate the flow of the dosing pump. So hope guys you understand the calculations of Oxygen Scavengers or biocides, and you got how to inject it. If you really getting benefited from my channel, please don't forget to subscribe my channel to have more interesting videos like this, and share it to your friends and hit the like button now to inspire me more. Signing off, Showman.